All right, so this is P6 part 2. We're going to talk about special products today. So we're going to skip ahead to the third page where it says special factoring formulas. So here we have our special formulas. First one we're going to look at is the difference of squares. So when you have two perfect squares that are being subtracted, so this only works when it's subtracting two perfect squares, it factors into a minus b times a plus b. So if I had something like x squared minus 4, x squared is a perfect square and 4 is a perfect square, so we would take the square root of both of these to figure out what like our a and our b are. So this would be x times x, and 4 would be 2 times 2. So this would break down into x minus 2 and x plus 2. So again, the order doesn't matter. If you wanted to say x plus 2 times x minus 2, that's the same thing. Next, if we have a trinomial, that is a perfect square trinomial. So here we have our first term squared, the last term is squared, and in the middle we have 2 times a times b, so which would just be this term before it's squared. So perfect square trinomial, it factors into a plus b squared. So that's when you have a plus in the middle, you've got a plus in the middle here. So it's a perfect square trinomial. Same thing with the next one, but when you have a minus in the middle, it just means that you have a minus in the middle here. And then we also have perfect cubes. So the difference of cubes factors into this. We'd have to figure out what our a and what our b are before we would cube it. And then we plug those in. So it'd be a minus b times a squared plus ab plus b squared. And then when you have the sum of cubes, it's the same thing, but the signs are different. So one way to remember the signs for perfect cube would be the acronym SOAP. So the sign in the middle, or the first sign, is always going to be the same as the sign that you started with. So same. The second sign is going to be the opposite. So here, since I started with a minus in the equation, the next sign is going to be a plus, so opposite. And then the last sign is going to be always positive. So same, opposite, always positive. So same thing works with the plus sign. If I have a plus sign in the question, my answer is going to start with the same sign that the question starts with, then the opposite sign, then always positive. So same, opposite, always positive. This works for perfect cubes. So when we're factoring perfect cubes. So if there's anything I would write down from this page, it would be this acronym here, just so you can remember the signs for perfect cubes. It's just a quick, easy way to remember it. Let's go right below it to example 6. We're going to be factoring difference of squares. So difference of squares, we start off with a squared minus b squared. Always difference. There's always going to be a minus sign in the middle. It factors into a minus b times a plus b. So we need to figure out what our a and what our b's are. So for example A, to figure out what a and b are, we're going to take the square root of both of our terms here. So figure out what this breaks down into. We'd have 2x and 2x. 2x times 2x would give us 4x squared. And then 25 breaks down into 5 and 5. So our a is 2x and our b is 5. So this would factor into 2x minus 5, and 2x plus 5. If you wrote it as 2x plus 5 times 2x minus 5, that's the same thing. These are both correct. These are the same answer. Let's do the same thing for b. So again, these are the difference of squares. We're subtracting two perfect squares. So when we factor this, we want to figure out what the square root of each of these are. So the square root of the first one cancels out with the squared, so it'd just be x plus y as our first term. And our second term, square root cancels out with the squared, would be z. So our a is x plus y, and our b is z. So when we plug that in, we have a minus b times a plus b. So x plus y minus z, and x plus y plus z. And we don't really need those parentheses on the inside, so we could write it as x plus y minus z and x plus y plus z. Since we're just adding and subtracting, you don't need the parentheses. So either way that you write it would be fine. The top one or the bottom, they're the same thing. All right, let's look at the ones on the next page. Number 1 is the same thing as A on the last page, so we just did that. Let's look at number 2. So this is the difference of squares. We square root both of these. So the square root of y squared would be y, so our A is y. Square root of 100 would be 10. We want to ask ourselves, what are two numbers that multiply and give us 100? Because we're looking, like this would be b squared, so we take the square root to find out what just b is. So that would be 10. So we plug it in, we have y minus 10 and y plus 10. Number 3, it's the difference of squares 2. So this is a squared. This guy would be b squared. We want to figure out what just a is and what just b is, so we would take the square root of both of these. So square root of 9 would be 3, and then we can't forget about that x there, and then the square root of 81 would be 9, and we can't forget about the y. So then when we write this out into our factors, it'd be 3x minus 9y and 3x plus 9y. Let's look at number 4. 4 is the difference of squares also. Be careful, because sometimes we may not think that it's the difference of squares when we see a 1 there, but 1 is a perfect square. So our first term is our a squared. We want to take the square root to figure out what just our a is, and then we want to take the square root of our b squared to find out what just our b is. So you don't have to do this step if you can clearly see what two numbers. I'm just writing it out to show you this is how we get that a and how we get the b. So a lot of difference of squares don't really require any work because you can just see, oh, these are my two factors. So 49 is a perfect square, it's 7 times 7, and y squared is a perfect square, it's y times y. And then 1 is a perfect square, so b would be 1. So this breaks down into 7y minus 1 times 7y plus 1. And again, you could write it with the signs flipped. You could say 7y plus 1 times 7y minus 1. It's the same answer. All right, next let's look at factoring differences and sums of cubes. So for cubes, we know that if we have a cubed plus b cubed, then the formula we use is a. The acronym we use to remember the signs is SOAP. Same, opposite, always positive. So same sign would be a plus b, then a squared. The next sign that we reach is going to be the opposite sign, so minus a times b, then always positive is a plus b squared. And then I'm also going to write the a cubed minus b cubed here too. So we have a, here it's same, so same sign as the question, minus a minus b times a squared, opposite sign now, so plus ab, and then always positive would be plus b squared. So now we want to figure out what our a and our b are. So we take the cubed root of both of these. So 27x cubed is a cubed. So we would take the cubed root, and we want to figure out what cubed gives us 27. Well, we know that that's 3 cubed, so just a would be 3. And then what cubed gives us x cubed? That would be x. So if I cubed this and cubed this, that would give us 27x cubed. So just a would be 3x. And then same thing with 1, we know that this is b cubed. So if I took the cubed root of both of these, cubed root of 1 would be just 1. So b is 1. So we're going to plug that in. Since it's a minus sign, we're using this formula here. So we start off with 3x minus 1 times 3x squared. Then the next sign would be plus 3x times 1. And then always positive would be plus 1 squared. So now we just need to do a little bit more simplifying. We have 3x minus 1. We have to be careful here because it's not just the x that's squared. We have to distribute the squared to both the 3 and the x. So this would be 9x squared plus 3x times 1 is 3x. 1 squared is 1. Now when you're using the sum and difference of cubes, you can't factor it any more than the formula. So once you plug it into the formula, you're done. The middle, like that trinomial that you have with it, this guy doesn't factor anymore. We just leave it the way it is because it can't factor. So this would be our final answer. Just for the sake of time, I'm going to skip B. I don't think that you have any sum or difference of cubes in the homework. We'll practice more on Monday, but I want to get to the perfect square trinomials down here at example 8. So trinomial is a perfect square if it's in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So you have to have that 2ab in the middle for it to be a perfect square trinomial. All right, so looking at A, we want to factor each trinomial. So we notice that x squared and 9 are perfect squares, but in order for this to be a perfect square trinomial, so we could use our formula, the middle part has to be 2ab. So we have to figure out what our a and what our b are and just check the middle part. So we would take the square root of both of these. So we figure out that our a is x and our b is 3. That means our middle part has to be 2 times x times 3, which would give us 6x. So since it's the same, we can use our perfect square trinomial. So shortcut. So what we do is we have a parentheses squared. Our a goes in the first spot, our b goes in the second spot, and then whatever our sign is goes in the middle. So it'd be x plus 3. It's whatever the sign is in the middle is the sign that goes in the middle of your parentheses. So our answer is x plus 3 squared. Now we don't use the 2ab part, but we just have to make sure that it's the same as the middle term in our trinomial in order to use this shortcut. So it's just something that we have to check. We have to check that 2ab and make sure that it's the same, but it doesn't go into our formula here. So just so I can write it for you guys, if we have a plus sign, so if we have a squared plus 2ab plus b squared, we're using a plus b squared. And then if it's a minus in the middle, it's the same thing, but it's a minus b squared. So next let's look at b. So we notice that 4x squared is a perfect square and y squared is a perfect square. So in order to use my perfect square trinomial shortcut formula, we have to check the middle to make sure it's 2ab. So we want to figure out what our a is and what our b is. So what squared would give me 4x squared? Well, 4 would be 2 times 2, and x squared would be x times x, so 2x. And then what squared gives us y squared? That would be y. Now I need to check the middle to make sure it's 2ab in my middle term there. So I have 2 times 2x times y. 2 times 2 would be 4, and then xy. It's 4xy in the middle, so we're good. We can use our shortcut. So the a goes in the first spot, b goes in the second spot, and my sign in the middle is going to be a minus. So I have 2x minus y squared. A lot of times people will get confused on when to use like your binomial squared. So one thing that I think is kind of helpful to remember, which we can talk about again when we practice more on Monday and Tuesday, will be if we have a perfect square trinomial. So if we have 3 terms, then it factors into a binomial squared. So just like one set of parentheses. Versus if we have the difference of squares, so that's like one term minus another term. So when we have two terms here, it factors into 2 parentheses. So if I had a squared minus b squared, that would be a minus b times a plus b. So 2 terms gives you 2 parentheses versus 3 terms gives you 1 parentheses. So in total, it adds up to 4 each time, just 4 things. It's just a little way to help you remember. If this doesn't make any sense, then you can forget about it and just memorize the formulas. But I think it's sometimes helpful. 2 terms, 2 parentheses, 3 terms, your answer is going to be 1 parenthesis. We're going to save factoring an expression completely for Monday, so that'll be part 3. And then also we have factoring when a is not 1. That'll be part 3 also. So you guys are now able to do part 1 and part 2 homework. So I would make sure you get that started so you don't save all of the homework for Monday night. Make sure you turn in the notes by the end of class, so don't forget to turn in part 2 notes to the part 2 notes assignment.